Hello cadets, we are group number 10 and for today's video, we'll try to discuss and comprehend the history of radar in navigation and to discuss the importance of radar to the mariners and the recognition of the ship's parameters.
Hi everyone, my name is Tero Marc and the science topic that we're going to cover is the Maritime Navigational Radar and learning outcomes. At the end of the session, the students shall be able to comprehend the history of Maritime Navigational Radar, determine why radar is such a valuable tool, recognize the ship parameters. History. New technologies of radar become available to merchant shipping with the end of hostilities in 1945. Radar on merchant ships was initially installed for commercial purposes. On ferries to maintain better schedules in fog and large fishing vessels. Next, radar was treated with great suspicion by the mariners. Next, with improving technology and after some time, the use of radar for safety purposes was recognized. Misinterpretation of radar information had not resulted in any reduction of the number of serious collisions at sea. The International Conference on Safety of Life at Sea in 1960 revised the international regulation for prevention of collision at sea by adding rules to take account of the use of radar and recommendations on the use of radar informations as an aid to avoiding collisions at sea. Next is the International Conference on Safety of Life at Sea in 1974 adopted provisions to the SOLAS conventions, making radar a mandatory carriage requirement for merchant ships in phased program starting in 1980, which finally complete in 2002. SOLAS requirements. All merchant ships of 300 gross tonnage and over now shall carry a radar and minor carrier too. IMO adopt performance standards for marine radars, which are used in integrations with other navigational equipment required to carry on board ships, such as an automotive target tracking aid, ARPA, EIS, ICDIS, GNSS, and others. Non-SOLA ships. Many small craft, millions, also carry radar voluntary as manufacturers have produced cost-effective design for their needs. The ship's master point of view, the key fact are that radar remains and will remain the primary system for collision avoidance and radar is very important tool for navigation. Why is radar such a valuable tool? The master and watchkeeper have confidence in information radar provides because its operation is ship-based. It's not reliant on third-party sources. It has a proven track record, and radar is useful with search when engaged in search and rescue. Next, in short. In its display, radar offers the watchkeeper's basic reality of all targets relative to the ships. It therefore aids the watchkeeper and helps in decision making for both navigation and collision avoidance.
So, collision avoidance. Early action is required to avoid a close quarter situation. Therefore, early identification of closing targets is essential. Watchkeeping officers need to be competent in the use of radar and are trained in its use and application of ARPA. So here are some IMO requirements. Maximum emergency stopping distance from full speed of the ship should not be more than 15 ship's length. Emergency turn radius of the ship should not be more than 2.5 ship's length. For the ship parameters, speed up to 25 knots and the length is largest container ship 335 meters, Cape size bulker 300 meters, Panamax 220 to 30 meters. And emergency stopping distance 3.3 kilometers to 5 kilometers or 1.8 nautical mile to 2.7 nautical mile. Emergency turning radius 550 meters to 840 meters or 0.3 nautical mile to 0.45 nautical mile. And displacement weight is 100 100,000 to 250,000 tons. For the practical requirements, to start plotting targets and determining their course and speed when the target is between 8 and 10 nautical miles off. Navigation. Radar gives accurate information and distance from charted features and assists in maintaining the ship's course. Radar will normally show a 60-meter high landmass at a range of 20 miles. This is considered by seafarers as a minimum requirement. Following slides will show you what's inside the monitor of the radar. Discrimination of targets from a watchkeeper's perspective. So, to be able to distinguish a tag from its tow at say at 12 miles range, approaching a rig on a supply vessel, to clearly identify the standby boat from the rig at 6 miles range, to be able to distinguish the anchor pennant buoys of a semi-submersible rig at 3 miles range.
Good day, I'm Cadet Jeff Aldrich Tigas, and in resolution MSC 19279 range, the radar system should be capable of displaying 2-point targets on the same bearing, separated by 40 miles in range as to distinct objects. And the radar system should be capable of displaying 2-point targets on the same range, separated by 2.5 degrees in bearing as to distinct objects. So why radar is very helpful during navigation? So radar greatly assists navigation during poor visibility, and pilots rely on radar at close range in reduced visibility to pass buoys and beacons.
Moment of time, we're running in restricted visibility. We have a speed through the water of 10.5 knots, and that seems to be safe for where we happen to be, the amount of traffic and the state of visibility for this ship. What I'm looking at is I have a target out here to starboard. I'm going to assess if that target is a risk to me. I first use my electronic bearing line. Left click turns it on, left click puts it on the target. I can then left click and drag the range reference in. Over a successive number of sweeps, probably about 3 minutes, I am looking to see if this target comes down my electronic bearing line. In other words, the range does not appreciably change.
Hey, I'm Cadet Vinculado Jessie Ray. So now I'm going to continue the topic. So RES MSC 192 parenthesis 79 5.4 minimum range 5.4.1 with own ship at 0 speed, an antenna height of 15 meter above the sea level, and in calm condition. The navigational buoy in table 2 should be detected at a minimum horizontal range of 40 meter from the antenna position and up to range of 1 nautical mile without changing the setting of control function other than the range scale selector. In engineering term, RES ITU RM 1313, power 30 to 70 kilowatts, horizontal beam width 0.75 to 4 degrees, pulse width 0.03 to 1.2 microsecond, PRF 4000 to 375 Hz, noise figure 3 to 8 dB, antenna, pitch 3 degrees, roll 25 degrees, yaw 5 degrees, so vertical beam width 20 to 30 degrees.